On May 1st, 2024, astronomers began noticing something intriguing on the eastern limb of the Sun, a relatively small sunspot emerging in a quiet region of the solar surface. At first glance, it seemed unremarkable, no different from the countless other sunspots that appear and dissipate during the Sun's 11-year solar cycle. However, over the next few days, this sunspot defied expectations, expanding at an astonishing rate. By the second week of May, this once minor blemish on the Sun's surface had grown into an enormous active region, now officially labeled AR 3664. Its size was staggering, spanning an area more than 17 times larger than Earth, making it one of the largest sunspots observed in the past 2 decades. Scientists around the world took note, as such immense sunspots are often harbingers of powerful solar activity. As its magnetic complexity grew, AR 3664 lived up to its potential. It began unleashing a series of solar flares, intense bursts of electromagnetic radiation produced when magnetic energy is rapidly released. These flares range from moderate M-class flares to powerful X-class flares, with the latter being the strongest category on the solar flare scale. Some of these flares were accompanied by coronal mass ejections, CMEs, massive expulsions of plasma, and magnetic fields from the Sun's corona. Unlike the fleeting radiation from a solar flare, CMEs consist of charged particles that can take days to reach Earth, depending on their speed. When aimed directly at our planet, these eruptions can have dramatic consequences, creating geomagnetic storms capable of disrupting technology and generating breathtaking auroras. A dazzling display, Earth under siege. By mid-May, AR 3664 had triggered a geomagnetic storm of historic proportions, as one particularly large CME collided with Earth's magnetic field. The resulting disturbance created one of the most vibrant aurora borealis displays in recorded history. Normally confined to high-latitude regions such as Scandinavia, Canada, and Alaska, these auroras were now visible in areas much farther south, including parts of Texas, southern Europe, and northern Africa. The skies were alive with color. Curtains of green light danced across the horizon, interspersed with vivid streaks of red, purple, and even blue. These colors are the result of charged particles from the Sun colliding with different gases in Earth's atmosphere. Green auroras are caused by oxygen molecules at altitudes of 100 to 300 kilometers. Red auroras, much rarer, occur when particles interact with oxygen at even higher altitudes, 300 to 400 kilometers. Purple and blue auroras are due to nitrogen molecules and ions reacting to solar particles. For many, it was a once-in-a-lifetime spectacle. Social media was flooded with images and videos of the phenomenon, as people marveled at the natural light show in places that had rarely, if ever, experienced it. The most intense storm in 500 years. NASA soon confirmed that the geomagnetic storm of May 2024 was the most powerful event of its kind in the last 500 years. Its intensity surpassed even the infamous Carrington event of 1859, which had long been considered the benchmark for solar storms. During that event, telegraph systems across Europe and North America experienced wild electrical surges, with operators receiving shocks and machines sparking flames. In the modern era, the stakes are much higher. Our global dependence on technology, particularly satellites, power grids, and communication networks, makes us far more vulnerable to the effects of solar storms. During the May 2024 storm, satellites in low Earth orbit experienced increased drag due to the heating and expansion of the upper atmosphere. Several satellite operators were forced to adjust orbital parameters to prevent their spacecraft from deorbiting prematurely. On the ground, GPS signals faltered, high-frequency radio communications were disrupted, and power grid operators in regions like North America and Europe issued alerts to prepare for possible voltage instabilities. Fortunately, the worst-case scenarios were avoided, but the event served as a stark reminder of the Sun's immense power and its ability to disrupt life on Earth. October 3rd, 2024, a new peak. The Sun's activity didn't wane after the May storms. Throughout the summer, it continued to produce frequent solar flares and CMEs, keeping space weather experts on high alert. Then, on October 3rd, 2024, the Sun unleashed an X9.0 flare, the most powerful solar flare observed in 7 years. Originating near the Sun's central disk, this flare was accompanied by a CME that was once again aimed directly at Earth. By October 7th, this CME reached our planet, triggering another powerful geomagnetic storm. This time, auroras lit up skies over Europe, Asia, and North America, with sightings reported as far south as Mexico City and northern India. The storm also caused brief disruptions to aviation and maritime communication systems, highlighting the vulnerabilities of modern infrastructure to space weather events. The solar cycle, understanding the patterns. To understand why the Sun has become so active, we must delve into the nature of the solar cycle. First discovered in the late 1700s by astronomers observing sunspots, the solar cycle is an approximately 11-year cycle of rising and falling solar activity. At the heart of this cycle is the Sun's magnetic field, which reverses polarity every 11 years. During this process, magnetic field lines become twisted and tangled due to the Sun's differential rotation. Its equator rotates faster than its poles. This twisting builds up magnetic energy, leading to the emergence of sunspots and increased solar activity. The cycle is divided into two main phases. Solar minimum, a period of low activity, with few sunspots and minimal solar flares. Solar maximum, the peak of the cycle, characterized by numerous sunspots, frequent solar flares, and powerful CMEs. We are currently in solar cycle 25, which began in December 2019. Early predictions suggested that this cycle would be relatively weak, much like its predecessor, solar cycle 24. However, by 2024, it became clear that solar cycle 25 was exceeding expectations. The broader implications of solar activity. One of the most pressing questions is whether heightened solar activity contributes to global warming. While the Sun's energy output does increase slightly during solar maximum, this increase is too small to account for the significant rise in Earth's average temperature observed over the past century. Instead, the primary drivers of global warming are human activities, particularly the burning of fossil fuels and deforestation. That said, solar activity does influence Earth's climate in subtle ways. For example, solar wind can affect the dynamics of Earth's magnetosphere and ionosphere, influencing weather patterns. Cosmic ray shielding. During solar maximum, the Sun's stronger magnetic field reduces the number of cosmic rays reaching Earth, which may have a minor impact on cloud formation. Looking to the future, the Sun's solar maximum is expected to last until late 2025, with heightened activity continuing for at least another year. During this time, scientists anticipate more powerful geomagnetic storms, intense auroras, and potential disruptions to technology. At the same time, this period offers an unparalleled opportunity to study the Sun and its effects on our planet. For stargazers and science enthusiasts, the solar maximum is also a chance to witness the aurora borealis and aurora australis at their most spectacular. Whether from the Arctic Circle or the southern tip of New Zealand, these natural light shows are a vivid reminder of our connection to the cosmos. In the coming months, researchers will continue to monitor the Sun, searching for clues about its behavior and preparing for the challenges and opportunities that lie ahead.